now that we know what transformations are, we're going to look at some problems where we're working with transformations. But let's first do a quick review on a high level of linear transformations that we have learned so far. If we have the equation y equals mx plus b, we learned that when the m, or slope, gets larger, the slope of the line gets steeper, and this is called a stretch. When the m value, or the slope, gets smaller but doesn't go negative, the line of the function gets less steep, or it flattens out. This is called a compression. When the sign of the slope changes, your m value changes, the sign of it, it is a reflection over the y-axis. And when the sign of y, or the whole function f of x, changes, the line reflects over the x-axis. We also learned that when you add a b value to your equation, that the line moves up on the y-axis, and this is called a translation up b units, whatever number b is. And that when you subtract a b value or add a negative b value, the line moves down on the y-axis, and that is called a translation down b units. So if you haven't written this down somewhere in your math notebook and you don't know this stuff, you need to write it down, study it, and memorize it. All right, and here's how we're going to use some of this. I would like you to make a table of values for f of x after the given translation, and I would like you to let g of x be the function after the translation, and the translation is 5 units up. Well, 5 units up, if you look back on your little review from the last slide, means that you added a b value of 5. So let's extend our table here. And we've said that g of x is going to be the name of our equation after we make our translation. And so if I add a b value, I'm going to take whatever my f of x value was, and I'm just going to add 5 to it. So if I do that for each one of these f of x values, I am going to get the following. And I just took each f of x value, and added 5 to it. Let's look at another one that we might do. I would like you to write the function rule for the transformation given below. Sorry, I didn't have that written down. I would like you to take y equals negative 4x, and I would like you to reflect it over the y-axis. Now go back and look at your notes. When you're reflecting over the y-axis, you are actually changing your m value, the sign of your n value. So if I look at my m value right now, it is a negative 4. So if I want to change the sign of that, I have to change it to a positive 4. So to reflect negative 4x over the y-axis, I am going to change this to y equals 4x. Let's write an equation for the transformation of the parent function y equals x. And I want to make the transformation a vertical compression of 3/4. Well, again, go back in your notes and notice that a compression is where you change the slope, or the m value. And actually, you're going to take whatever this compression is, and you're going to multiply it by your m value. So now we never write this down, but y equals x is really y equals 1x. So if I take 1 times 3/4, I'm going to get 3/4. So to write the transformation of y equals x with a vertical compression of 3/4, it's going to be y equals 3/4 x. Let's see if we can write the function rule for g of x after the given transformation of f of x. And f of x is negative 15x. Well, they're asking us to do two things here. First, they want a reflection over the x-axis this time, not the y. oops, sorry. And then they want a compression by a factor of 1/5. Well, remember that reflecting over the x-axis means that you change your y value or your whole function. You change the sign of it. So let's do our reflection first. If f of x is negative 15x and g of x is a reflection over the x-axis, then that means it's a negative f of x. So let's substitute in, instead of f of x, I'm going to substitute in the actual equation, which is negative 15x. Now, I'm hoping you can see how these two negatives cancel each other out, and so I get that g of x, after a reflection over the x-axis, is positive 15x. All right, now we have to do a compression by a factor of 1/5. Now remember, when you're doing a compression or a stretch, you're multiplying the m value by whatever the compression or stretch factor is. So this means I'm going to take g of x equals this compression factor of 1/5. I'm going to multiply it by my m term, which in this case is 15. So I'm going to get that g of x equals 3x. And I'm hoping you can see that this is after a reflection over the x-axis and a compression of 1/5. So that is my answer. G of x equals 3x. You'll have a few problems like this. Make sure you're taking good notes. All right, what if I want you to describe the transformation f of x that produced g of x? Now I'm giving you two equations here. One is f of x and one of g of x. And let's see how they're different. Well, first let's look at their slopes. F of x is 5, g of x is 5, 6. So I know, since I'm going from a large number, 5, to a fraction, 5, 6, I've had some sort of a compression here. And here's how I'm going to figure this out. If I took my slope and I multiply it by something, let's just call it v, some value that I'm compressing by, I got 5/6. So if I solve this for v, I would get that my compression was 1/6. So I had a compression from f of x to g of x of 1/6. Now let's take a look at this. Now I have -7, and here I don't have anything. So going back and looking at my notes, when I add a negative b value or subtract a b value, that is a translation down. And in this case, it's a translation down of 7 units. Notice I did not say -7 because the down indicates the negative. So I translated, this is a compression of 1/6 and a translation down of 7 units, going from f of x to g of x. And those are examples of the types of problems that you'll have. I think you're ready to start your assignment. Thanks for watching.